So far, what have we said about Euclidean geometry, particularly the proportionality theorem? Well, we do know that we have discussed the proportionality. We have discussed the proportionality theorem, right? And we did say if you have a triangle, and then that triangle happens to have a side that is parallel to the third side, right? A, B, C, D, E, right? So what you can conclude is to say AB over BC is gonna be equal to AD over DE. We said, what is our reason? We say we use line parallel to one side of a triangle. And the last time I gave you the ways in which you can attack problems. If you can remember very well, I said if you are looking for a certain side, right? If you are looking for a certain side, you are gonna say want over given, right? Then you match. We match using the triangle that has what you call. So we match using a triangle that has one side which is parallel to the third side, and therefore we use the reason line parallel to one side of a triangle. If you are looking for a ratio, this is what we said. We said if it happens that you want a ratio, you simply write the ratio as a fraction. So you write it as a fraction and then you match there. Then you use line parallel to one side of a triangle. Right? It might happen that you immediately have to use this, or it might happen that you need to wait a bit so that you can match it and then see the missing side that you don't have. Then it becomes your want there. You see, it becomes your want. Please, guys, you should, if you didn't watch the last recordings on Euclid, I would highly recommend you go and watch them. I think I sent you more links on this thing, right? So that you can have access to everything. So please go there, watch those things, get familiar with how to do this Euclid thing. Yes. Immediately after this, we have a test on Euclid. So I'm just gonna send it. It's already prepared, done, and ready, dished already, just waiting for you guys. So please, we need to do what? We need to make sure that we watch the recordings and we are aware of what's going on there. Okay. Now, let's see. We're just gonna check if maybe we have other problems here. Okay, these problems, all of them, they're dealing with something else. All right, so now we're just gonna check here a revisit on areas, ne? A revisit on areas. Let's remember that if we have parallel lines, right? We said one of the properties of parallel lines is that if I have parallel lines, I know this line is parallel to that. Then I happen to have triangles. This is a triangle here, and then maybe this is another triangle there. Oh, it must be like this. We know that A, B, C, and say D. We know that those triangles A, B, C, and D, B, C, they are both going to have the same area. Okay, they're going to have the same area. Why? Because remember, they have same base and the same height. Same base, same height, and they are what? They are between parallel lines. That is what is very important there. This is something that we are already familiar with. Now, if I were to draw another triangle, which is not here, which is not having the same base, let's understand that even though I might not know that the base here for this one is equal to that, the bases are not the same because they're not sharing the same base, but the heights are going to be the same for all those triangles. The height is going to be the same. So this is something that we need to make sure that we remember there. Yes, we got a question. You can just talk to me. Yes, Miss Yolanda. Talk to me, Miss Yolanda. Any question? No question. But are we able to see the screen, guys? If you can see the screen, just raise a hand for me so that I see. Oh. Okay. No, that's perfect then. We can then proceed. We can then proceed. So this is what we said. Now, speaking of areas now, the problems we're gonna look at today, they're gonna be having a strong focus on areas, right? These questions like this, let me just show you here. We need to be able to master them. Now, I told you I like examples from mind action. They're very good examples. So here's a question here, and we need to find the area then in this sketch. We need to find the area. Now, where do we even start with a problem that is like that? Where do we start, right? The first thing is that because let me just okay. So because the triangles, we can see parallel lines, right? So we do know that our proportionality theorem is gonna be applying somewhere. So we're told that in this sketch you have AE, which is parallel to BD, and ED to DC is equals to 5:12. So the first statement there, that AE is parallel to that, AE is parallel to BD. This is AE, this is BD. Now if they are parallel, do we have a triangle there? No, we don't have a triangle. If it was like this, we're gonna have a triangle, but we don't have a triangle that is using those two parallel lines if we check properly. And then they were told that ED is to DC is equals to that. So remember, ED is here. If it's 5, remember we put K, and then DC is 12. So we have 12K. Yeah. So they say to you, determine the area of triangle ABD over the area of triangle BDC. Wow, very good question there. Quite interesting question. So the area of triangle ABD over the area of triangle BDC, how do we then get it? Oh my goodness. Okay, it's fine. So for ABD, focus on the triangle ABD. ABD. What can you see in that triangle, guys? It seems like an ordinary triangle, but what is its base there? Which one would you say is the base? Which one would you say is the height? We need to be careful of that. Ne? You need to be very careful of that. And then now BDC, check now, BDC is which one? So BDC is this one, BDC. Aha, those are your two triangles there. Look, right, those are our two triangles there. Now, can we be able to find the area of triangle ABD? Now, I just want to ask, which one would you say is the base, guys? Can you just type for me, anyone in triangle ABD, which one would you take as the base in triangle ABD? Talk to me, guys. Right. Mr. Fatai said AB. I see AB is the base, BD is the height. Okay, AB is the base, AB is the base. Wow. AB is the base. Okay, that is at least very good, right? That you could identify that we can take AB as the base. Now, here's a challenge here. The thing is that, remember, we're saying if I have parallel lines, right? If I have parallel lines and I have triangles that are sharing the same base, then I can say those triangles have the same area. That's what we know. Now here our parallel lines are here, so we should focus there. Guys, I know you might not be able to do this, but you can do this in the exam, right? Whatever I'm gonna do right now here, I know you can also do it in your exam. So this is what you can do. Look. So you can look at them this way. This way it will be much easier to, analyze them. So since you are looking at triangle ABD, look at this base, Look at this base and then you look at triangle EDB. You see, they're sharing the same base. Triangle ADB and EDB, they have the same base, which is BD. So, and they are also between what? They are between parallel lines. Let's remember that they are between what? Parallel lines. Now, the fact that they are between parallel lines means that this triangle and that triangle are going to have the same area. From the get-go, you don't have to do any calculation. What you should understand is that ABD and EDB are actually having the same area. Okay, so I'm talking about this blue triangle, and let's make maybe a yellow triangle, and this yellow triangle here, and this yellow triangle here. Because they are sharing the same base, that means those two are gonna have the same area. Okay, they're gonna have the same area. So we can therefore say that, okay, so this is the same as saying area of triangle EDB over the area of triangle what? BDC. Right. And why are we doing that? Or rather, why are we saying that? This is because the area of triangle ABD is equal to the area of triangle EDB. Okay, why? Because they have the same base, same height, and then they are between parallel lines. They're between parallel lines. So guys, using that only, we can be able to tell that those two have the same area. Now, them having the same area, what is it going to assist us with? Is that we are now working with this expression. So guys, I'm gonna try and just maybe rotate it a bit again, right? So that it can go back to the normal position. Wow. Okay, I'll just leave that there. I'll just leave that there, guys. We can focus this side. Yeah, we can now focus this side, whereby it's straight like this. So now I said to you, the focus now is looking at the area of triangle at this triangle, the area of this triangle AED. Okay, is it AED? No, it's not AED. We said it was BED. It was BED because it was sharing the same base as this other triangle that was here. Okay, so now we have area of triangle what? EDB over the area of triangle BDC. Good. Now, where is BDC? Let's remember that this is BDC here. This is BDC. This triangle here. That's your BDC. Right. That's your BDC. And then we have EDB. Now, one might ask now, so I say, what is going to be the relationship of BDC and BED? And why did you choose BED? Why are you discarding the fact that we started with ADB? Right? Trust me, I hear your cries, okay? I hear your cries, but I want you to focus on something. I want you to actually know something, okay? And this is something that is going to assist you in most of these area type problems. Something you should understand, guys, is that whenever you have a situation like this, and then I draw something like this to you, and then I say I have two triangles, I need you to understand that those two triangles there, we can actually, relate their areas because they're going to have the same base. They're going to have the same height. Whenever you have a situation like this, guys, know that your triangles there, they're going to have the same height. Which triangle am I talking about? You see this triangle here. You see this smaller triangle here. And then that bigger triangle there. And this bigger triangle here. Let's maybe use a red. This bigger triangle here. And then this one that is inside. Can we use a black? This one that is inside. You see all those three triangles, right? I want you to understand that they're going to be sharing the same height. That's the beauty of them. They're going to be sharing the same height, which is what? Which is the height that would be drawn here. The height that would be drawn here, that is perpendicular. You understand? If I can label it a bit to say A, B, C, D, I'm talking about triangle ABC. I'm talking about triangle ACD. I'm talking about triangle ABD. All those three triangles, they are going to have the same height. When you're calculating the area of triangle ABC, you're going to say half BC. This is going to be the base, right? This is going to be the base. But remember, it's an obtuse angled triangle. Where do we find the height of an obtuse angled triangle? We find it outside, and which is going to be this height. You see? So it's going to be times that height. Let's look at triangle ACD. Triangle ACD is this one. If I'm looking for its area, I'm going to say half of CD, which is this one, times the perpendicular height. Because the perpendicular height is inside. Right? So times that height again. And let's look at triangle ABD. You have to understand that ABD, the base is going to be BD. Right? BD. But what is going to be the height? Is the perpendicular height, which is that one. So all of them, they're going to have the same height. That's a beautiful, beautiful, beautiful observation you can always use to find areas easily. You understand me? So all you need to do, what I need you to have as a picture in mind when you go into the exam, just draw a triangle like this, and then make an obtuse angle triangle by doing this. Or make an obtuse angle triangle by doing this. You have to understand that the area of this and the area of that and the area of the bigger one, they all have the same height, which is this one. Guys, if you know this, we are done with this. In fact, you know what? The lesson is over, guys. Let's just go home, rest, and sleep because we are done here. You understand? But you know what? Let's actually apply it. Let's actually apply it. Now, Mr. Rohan, you are here. Glad to see you, man. So, right, how do we apply this thing? Now, check. That triangle is here. Look at it. BEC. That's why I was looking for this triangle instead of the one that they gave me. That's why I wanted to focus on this one. Now, the nice thing also about this one is that we were told that ED is 5. So, we have 5K here. And then we were told that DC is 12. So, we know that this is 12K. Now, guys, what is the area of triangle EDB? This one, the yellow one, is the same as this yellow one, right? The base will be this one. So we'll say half of ED times the what? The height. Where is the height? Guys, the height is going to be the perpendicular height here. That's where you're going to have your perpendicular height there. You see? Same as this height there. So now, because it's an obtuse angle triangle, it has an angle that is bigger than 90 here. So it's an obtuse angle triangle. The height will be outside and it's a perpendicular height. So that's why it's H. What about for BDC? Remember, BDC is this one now. BDC. What is the area of BDC? It's going to be half of DC, right? Just as we had AC, what? I think we had AC D. You see, we took this as the base and this was the height, the same height. So this will also be the base, which is DC, times the same height. Now you know mathematics, guys. What is going to happen? Height cancels height, half cancels half. So you have ED over DC. Wait a minute. Are you not given ED? You were given that it's 5K. Are you not given DC? You are given that it's 12K. So the answer is just simply 5 over 12. Done. Done and dusted. So that's why I just need you to have this triangle in mind. Right. Now, if you think that was luck, let's go to the next question. Now, this question is going to be quite intense. We're going to calculate so many areas there. So many areas. But we are doing this until we can say, and you know what? This thing I now know it, shame. Even from the back of my head. But life science students will tell us that, hey, we don't have a vision at the back. Right, okay guys, this is a question here, right? And we need to find the areas. Look at how beautiful this thing is. Very, very nice. Now the question is, can we find those areas that we want? Let's find out. Where are the parallel lines? Look, this is AF is parallel to DE. So because those two are parallel, do we have triangles that are in between here? You know, if we had a triangle like this, and the triangle like maybe this, you know, and then maybe, yeah, so we would know that this triangle here was going to have the same area as this one here, because they were sharing same base, same height between parallel lines. But they are not there. Let's not make up things that are not there, guys. But you know what is there? You know what is there? Let me show you. Let me show you. Bona. Wow. Don't you recognize this? This thing is familiar. Let's check at the top. How beautiful. Welcome back, my friend. It's exactly the same thing. So we should be happy and celebrating, guys. So now what we can do here is simply just, get our stuff. Now, the nice thing about this one is that now we also have a triangle that follows proportionality theorem. This is the triangle here. Look at this triangle here. It follows the proportionality theorem because you have parallel lines there inside. So let's keep that in mind. It's going to help us with the sides. Let's actually start. They say AD to DC is 2:5. This is AD here is 2K, and then DC is 5K, right? And then BF is how much? Is 2, so we use 2P, and then FC is given as 3P. This is what we have, guys. This is a very, very beautiful question. In fact, a classic question from what we were doing the last time. Before we even answer the question, let's actually deal with getting the information, as much information as we can from this. So, first thing is first, I don't have FE. We don't have FE. We need to get FE. Miss Chanez, the moment I say I need to get FE, FE becomes my want. So I immediately I'm going to say my want, which is FE. That's my want. What is the given side along FE there? I'm given FC. Isn't that right, Mr. Fatai? I'm given FC, so it becomes my given. So I'm just simply going to say FC is equal to, then I simply play Candy Crush. I match FE with AD because we know that we're working in this triangle. So AD over what? FC. and FC is going to be AC there, okay? You use line parallel to one side of a triangle. Now we don't have FE, it's our want, and then the given one is 3P. What is AD that side? Is 2K. What is AC this side? Is 7K. When is Porsche. So FE over 3P is gonna be equal to 2 over 7. So when you multiply by 3P both sides, these cancels that. But when you multiply by 3P here, you end up having what? 6 over 7P. So now you know that this is 6 over 7. 6 over 7P. Beautiful. If FE is 6 over 7P, you can get EC now by saying 3 minus 6 over 7. Miss Portia, please assist us with a calculator. 3 minus 6 over 7. What do you get? 3 minus 6 over 7. You got it sparsely. What do we get? 15 over 7. Beautiful. That's 15 over 7, guys. 15 over 7. So we know that here it's 15 over 7P. Beautiful. Now that we have that, guys, we've filled the information we wanted, right? We're just on an ad break there. Let's go back to the main question. So the main question says now determine the areas, right? Let's start with the first one. The area of triangle ABF, this is ABF. The area of this triangle, right? Remember, ABF, you know what it reminds me of? It does remind me of the yellow part. So I don't have to stress. That means I must actually have a height first before I can even do anything. So I'm going to have my height here. I'm going to just construct a big perpendicular height there. This one. Then I'm going to call it height H. Okay. So triangle ABF, I know that the area is going to be half. Since it's ABF, it's half BF multiplied by the height, which is this height. And then what is ACF? Look at ACF. ACF. How banna? You can see the base. Can you not? It's FC. Ne? So it's FC, half of FC, multiplied by the same height. Multiplied by the same height. It reminds us of this one. Okay. So now what's going to happen there? Height and height cancel. Half and half cancel. What is BF? Is 2P. What is FC? Now remember we got our FC, or our FC is given already, is 3P. We don't have to worry about that. So the answer is simply 2 over 3. Easy stuff. Quite easy, smooth. Perfecto. Let's go to the next one. We need the area of triangle ACF. Now this is ACF. Ow. The same one. This guy's so let's just say half of FC, guys, multiplied by the same height. And then they want ABC. Which one is ABC? How? Yes, when I look at this problem first glance, I thought it's a difficult problem. Cantino. This thing is too easy. So we have BC there. Half of BC, guys. Half of BC multiplied by height. What happens? Height cancels height. Half cancels half. Right. FC is how much? FC is 3P. How much is BC, by the way? It's 2P plus 3P, which is what? 5P. So simply we get 3 over 5. Easy stuff. Let's go to this one. How banana? Another ACF. No. ACF, we're tired of you, but then it's fine. It's gonna be half of FC multiplied by the height. What about DCE? This is DCE. Where my daughter? Yeah. Now you know where the danger is. The danger is there because now, when you look at DCE, DCE now, it's not having this height is not for DCE because the height for DCE is actually here. You see that? The height for DCE is actually there. But guys, Mamela, listen to what I'm going to tell you. Knowing where the height of DCE is, right? It's actually gonna open a vault of opportunities, right? So let's just see. Let's put the height here, and that height we have to call it K. But we must call it K. So the thing is that now we see that we don't have, okay, we can see the base, ne? We can see the base, and then but the heights are not the same. So because they are not the same, yeah, that's gonna be problematic. So guys, which one are you gonna take as your base if something is like this now? Is it difficult? Seems difficult? It's not. It's not. It's not. You know what you must just do? Shift your perspective. I'm gonna try and because I don't wanna mess up my drawing. The drawing is too nice here. So I'm just gonna try and take a screenshot of this. Mr. Fatah is saying EC. Yes, sir. But you know the problem with that is that now our height there is going to be this part, which we don't have. Our height is gonna be this part. If we say EC, half of EC times the height there, we don't have any relationship of that height with h. Remember, this one we already have h, so we need to relate it with, you know, this thing is, you know. But then let me just show you, if things get like this, right, you don't have to worry too much or panic too much. I'm just gonna try and take a screenshot. Hopefully technology will allow me. Okay, so let's see. I have it here. So what I would do, I want to be working with this while we are also on this page. I'm not sure if that's gonna work. Yeah, so let me just take this. Let's put it here. It's the same diagram, guys, but you know what I'm gonna do? I'm gonna rotate. Now I always say that if you are rotating your diagrams in the exams, no one will penalize you for doing that, because you want to see. If they penalize you or say what, you tell them, hey, so you write the paper then. Then they won't do anything. So guys, now check here, right? This is the diagram. I've just rotated it. Okay, if I rotate it back, you see that is the same diagram. If I do this, it's the same one. Now I just rotated it like this. Why did I do that? Well, this is because if I actually rotate it like this, right, we're still talking about DCE, which is this one. DCE, right? That's the one we still are talking about. Now, let's see. If we say DC is the base, what is gonna be our height? Our height is gonna be K again. Our height is gonna be K. And if the height is K, is there another triangle we can relate that with? Let's see. ACD, what's gonna be the height for ACD? It's gonna be this one. That's gonna be the height for ACD there. Right? So if we say DC, guys, we can you see? Can you not find your area there? Right, talk to me, guys. You must be identifying this. Talk to me, Mr. Rowan. What do you see there? What do you see there, sir? Do you see that we can find the area of ECD? Yeah, DCE, not ECDE. Anyone? Miss Ngovile? Can you come to our rescue, ma'am? Or maybe Miss Latita? Yazi kunzima. Kuzolunga, guys. Latita? Miss Latita, can you see something there? Any area you can give us, you know, sites we can work with? Sparsely? Any information, insight that you can see and you can, you know, that can help us? Hey. No, you know what? You know what? The answer lies with Miss Alwandi. Yes, Alwandi. Just talk to us, ma'am. What do we do? Miss Alwandi, what do we do there? Mr. Fatai. Aye, Munna. I'm trusting on you. Mr. Fatai. Mr. Fatai says he's blind. He's blind, but he can see the problem. He's just blind to the answer. But the problem he can see. Hey. You know what? Ladies, women power. Guys, Miss Portia, assist us, Pella. You know, we need to get out of this mess. We just need to find, you know, I already did the first part for you. You know, I found the area of ACF. That was the most difficult. So when I'm just giving you the easy one, area of triangle DCE. How do we get the area of triangle DCE? Yeah? No one? Guys, you see now, I'm even now running out of time. So, should we leave it as a homework, guys? We leave it as a homework. Is it difficult? But I believe we can do it, guys. It's not difficult. Okay. So, let's check what we can do there, right? We already found AD over, it was AD over DC. We related it to FE over EC, right? We got that, and it's okay. Now, for ACF, right? For triangle ACF, we already said it was FC, ne? We said it was FC. But I want you to check something, right? I want you to check something. Right, let's see. We said we used FC here as the area of as the base, right? As the base of ACF. We used FC. If we check it from this angle here, the same area for ACF can be found by saying the base is AC. Yes, I think there was a question there. Yes, Mr. Fatai. To go to AC then, eh? Yeah, to go to AC. But let's see, which one is DC and EC? Check. We have DC here and then EC. So I want you to see something. The thing is, guys, when we are working with Euclid, ne? It doesn't exclude other. In fact, it's the whole of maths. If you're working in functions, it doesn't mean that you are not going to be dealing with geometric patterns. Or if you're working with what you call maybe geometric number patterns, it doesn't mean that you can include like ab nature of roots there. Good people, you always can incorporate 2 fields of maths or 3 or 4 or even more into one problem, as long as it will assist you to solve it. So why am I mentioning that? Now you can see that, guys, if we're trying to use this method here, we're not gonna win, shame. We're not gonna win. I think the main reason, let me still put 5k. It was what day we put DC, we said it was 5k, and then AD we said it was 2k. So because we're relating this triangle, which is ACF and DEC, the problem with them is that they don't look like the one that I showed you here. The one that I showed you here, the line must start from the top, from the apex, and then must go to the base there, you see, meaning that the line must be here and then it goes down. Then we can work with those triangles and use the area formulas, you see, half base times height. But if now this one, this line here is not starting here, so that means we have a whole different thing. We have something that is like this. Oh, that is like this. Now if it is like this, right, does that mean that it's impossible to solve it? No, it's quite easy to solve, guys. The thing is that they are sharing something here. What is this that they are sharing? They are sharing the same what? The same angle. They're sharing the same angle. If you look at angle C, it is in DEC and it's also in AFC. Do we agree with that? They're sharing the same what? Angle. Then you're gonna say, but Minier, how does that help you? Well, it helps you a great deal because they're sharing the same angle. Now you can write it as what? You can say to get the area of triangle AFC, it's going to be half of AC times, and get its ACF, which is this one. This one here, ACF. Like this. So now you can say what? You can say half AC multiplied by FC. And then times what? Sine of angle C. What is that rule there? Yes, I know you're shouting that rule. It's the sine rule, Menier. Yeah, that's the sine rule. Who said it doesn't apply because it's Euclid? No one. It still applies because it's still mathematics. So you're not constricted to just using the area for triangles. You can also use the area rule. You understand? So the area rule deals with, I usually say it's just deals with Vivian. Who's Vivian? It's a V. If you have this side known and this side known, the angle inside is called an included angle. Whenever you have a situation like that, you can use the cosine rule. And then if you know this and that, and then you know the included angle, you can use the cosine rule. You can also use the area rule. That's the beauty about Vivian. So if you have two sides known, and those two sides, they make up the angle in the middle, that angle is called included angle, and you can use it to find the area of triangles. Quite cool, right? So how does that help me? I found ACF. Now I can also use it to find DCE. Since DCE is here, what am I gonna say? Check. I'm gonna say half of DC multiplied by half of EC, because that is the V. You just have to check the V. That is the V here. Here, this is the V here, guys. This known side and this known side and the included angle. This known side and this known side and the included angle. That's your V there. So you can say half of DC multiplied by half of multiplied by EC, then times sine of angle what? Angle C, which is the included angle. What is the beauty of that? C angle sine C will cancel that, half will cancel that. And then AC, we know that it is 7K. Right? We know that it is 7K. What about FC? FC, we know that it is 3P. Right? 7K times 3p. What about DC? DC, we know that it is 5k, right? And then what about EC? We know that EC was 15 over 7p. So because of that, what will happen? Easy stuff. P cancels P, K cancels K. Then you put the rest in your calculator. You put 7 multiplied by 3 divided by 5 multiplied by 15 over 7. Then you get your ratio. Quite cool, isn't it? Quite beautiful. So guys, this is gonna assist you a lot. Trust me, we are going to similarity. So this is gonna be very, 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 very helpful. Make sure that you know it from today, okay? That if I have two known angles or that are making a V and the angle is inside, I can simply use the area rule. I'm not just confined to a, what do we call this? I'm not just confined to a half base times height. Are we okay, Mr. Fatai? Okay, guys. Are we all happy with this? Mr. Rohan, is this okay with you? Okay. All right. No. Okay. You still with us, Miss Portia there? You understand the V method, Miss Nobile? Yeah, I see also Spahle there. And I see Miss Latita there. All right. And Miss Shanez, you're still with us, man. Good stuff. So I don't know what you get if you put in your calculator, just to, net for control in J. What you get is the answer. Just for control, just for the sake of finishing that thing there. Please just type the answer for me there, okay? So let's look at the last one, the last question there. They put a star. The nice thing about this book, when they put a star, you know that, yeah, it's going down. So I like those type of questions because they require you to think and think and think. And then after doing that, you think again. Okay? So the area of triangle ABF. So let's look at triangle ABF. 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 This one. The nice thing about that one is that, remember, it is in the bigger triangle whereby we knew the height. We knew the height here. So we know that if it's the area of triangle ABF, the height is this one, the base is this one. Then they say DCE. Guys, where's DCE? DCE. Now, that DCE is smaller than this one. Correct? That DCE is not part of this normal triangle that I gave you. Nah. So because of that, we need to be quite careful there. In terms of how we're going to solve it, we need to be quite careful. Now, so it's DCE again. But it's not gonna, it's gonna be that challenging. If we use the normal method, right? If you use the normal method, this is what you would say. Guys, starting to become too messy here. I'm not sure if you can still see. Hopefully you can still see. Triangle ABF, you can still try to say half of BF times the height. And then you say for DCE, you still use the same area sine rule. Half DC, EC, sine angle C. But the problem is that there's not going to be any relation. Here you don't have height and you have height. You must have things that are quite similar, and so what can we do there? Can you look at it? Give it a thought. How can we get the area of ABF? We can still use our, we can still use our, yes, talk to me. Yeah. Oh, Miss Alwanda says 49 over 25. Thank you so much, ma'am. 49 here over 25. Okay, yes, talk to me. Yeah. Yeah. AF is parallel to D. Yes, it is parallel. So what is the goal? Maybe okay, yeah, no problem. Yes, you're allowed to use that. You are allowed to use that. What can we do there? Any idea? What can we do there, guys? Okay. My time is run out there. The session is gonna end. But guys, think about it. Think about it. If you can get it, I'll buy you a car. I promise you that I'll buy you a car. Just to show me how to get the answer there. I'll get you a car. We'll deliver it tomorrow latest. No, within 7 business days, we'll deliver it to your doorstep. Just try to find the answer there and send to me. Ne? And then I'm going to send you a link so that we finish it off. Maybe look at the corrections. Yeah, we will look at the corrections. But we'll start, let's just say 10:15. Yeah. Quarter past. No. Let's start now. Yeah. Beautiful question. You got it, say. Almost done. Oh, that's great. Are we winning, Miss Latita? Are we getting it there? Yeah. I'm waiting for the winner of the car. Guys. Get yourself a chance to win a car. Just solve number 4, right? Solve number 4. Whether you are close. If you are close, instead of giving you a car, instead of buying you a car, we'll buy you the keys of the car. Then the other competitions, you'll then win the car, you see. So now we just get you keys only to hold on, you know. Yeah, so if you are close though, right, that's if maybe you show me with it, but I was about to get it. So let's see. Right. Anyone, guys, remember the competition closes at exactly 14 minutes past 10. 14 minutes past 10. The competition has closed. I'm serious, guys. You stand a chance to win a brand new car, a brand new one. I'll make sure that I deliver it there, that side, to you, right? Yeah. Just get that number 4 there, that challenge question. Okay, guys. Yeah, no, the time is up. The time is up, guys. Yeah, anyone who managed to get it? Anyone who managed to get it? Mr. Fatai? How fast, eh? You were a very promising candidate. Yeah. Okay, you can send it there or analyze there. You can also send to me, guys, maybe what you are thinking there, or maybe what you came up with there, right? You can also send to me. Now is the time. As before, we look at the corrections and then we summarize what we're saying about areas so that we can simply look at similarity, which is the last part of Euclid. But we also have midpoint theorem though. I just need to know midpoint theorem. You can send it, sir, and then I'll just keep on. I'll check it there. Okay, guys. Now, this question, it's not very hectic. It's not very hectic. It works on the following algebraic fact. You know, students who are doing chemistry, they might be familiar with this. But if you're not doing chemistry, it's fine. It's not a train smash. It's let's say if I have 2 over 3, if I multiply it by 3 over 2, the answer that I get is 1. I think we can agree with this. I think this is something we can agree with. And then if I have 5 over 7, I multiply by 2 over 6. By 7 over 6. I believe these would cancel, and then you're left with 5 over 6. If I have 2 over 3, then I multiply by 3 over 5. My answer is gonna be 2 over 5. If I have 8 over 9, I multiply it by 9 over 6. I can have myself 8 over 6. I think we're still together there on this. It's just simple algebra, guys, but I want you to see if there is a pattern. If I have 1 over 7 and then I multiply by 7 over 8, my answer is gonna be 1 over 8. If I have 6 over 5, I multiply it by 5 over 10, my answer is gonna be 6 over 10. Should I keep going, or do you get the pattern there? If I have 4 over 9, if I multiply by 9 over 2, my answer is gonna be 4 over 2. Okay, that's fractions there. But why are we wasting time here? Well, let's look at the problem. The problem is looking for area of triangle ABF over the area of triangle DCE, of which if you look at ABF, which is this one, and DCE, they don't have any direct relationship. They don't have any direct relationship. Now when I say they don't have direct relationship, I'm meaning that number one, they don't share the same height, because if they were sharing the same height, we were going to use our famous method here. They are not sharing the same angle. If they were sharing the same angle, now we know that we can use sine rule. So they're not sharing the same angle, because this angle is not equal to that. No angle is equal to the other there, right? And at the same time, they don't have the same height. So if these things are not sharing those properties, do not despair. Just go back to the questions we did before, or maybe just try to, just go back to the questions we did before. I want you to check something. You will see that there is a relationship. Okay. Oh, Mr. Fatai, you gave up on it, man. It's fine. Okay, check. ABF, ne? This is ABF. Now, if I check, there is also ABF here, right? On this one. So let me write it. Let me write area of triangle ABF, and then divide by area of triangle ACF. Multiply by, where is triangle DCE? This is triangle DCE here. So let me just write that one. Area area of triangle ACF, all divided by area of triangle DCE. Now what do you see there, guys? This and that, they cancel, isn't it? Then what are we left with? We are left with ABF over DCE. So before I cancel them, right, I'm gonna find I'm gonna put them as the answers that I had gotten. But do we agree that if I cancel here and I cancel that, whatever I have here is exactly the same thing as that? It's gonna be area of triangle ABF over area of triangle DCE. Exactly the same thing we had when we said if I have 8 over 9 and 9 over 6, if I cancel these two, my answer will just be this over that, this over that, right? This over that, right? So similarly here, if I cancel this one and that, my answer is simply going to be this over that, which is exactly the same as that. So I'm gonna have the same thing, okay? But instead of cancelling and then writing it back as area of triangle ABF over area of triangle DCE, instead of doing that, because I'll be going back to the same question, instead of doing that, because I know that this times that gives me this, I can simply substitute what is area of triangle ABF over ACF. Remember, we had gotten it as what? We had gotten it as 2 over 3. And then what is the area of ACF over DCE? We had gotten it as 49 over 25. So if I put that in my calculator, that gives me my answer, guys. So I don't know what that gives you there. So if I quickly use my calculator, 2 over 3 multiplied by 49 over 25, the answer is what? 98 over 75. Then you are done. Oh yeah, so that's gonna be the answer there. Quite tricky, ne? But don't be discouraged, guys, okay? It's just that they put a star on it because it was just a challenge question. You know, you needed to think way deep, like I told you. But then let's summarize what we have talked about so far. Let's do a beautiful summary. So if you can summarize now, we said if we have triangles that are looking like this, and then you have a line either that is like that, or you have that same triangle, but then this line is not here, instead it is drawn here. Right, we said if we have these two cases, okay, if we have these two cases, then we just have to draw the height. Those triangles, those three triangles, they share the same height. So here we say those three triangles share the same height. And because they share the same height, that means that it's easy to, we use the formula area is equals to half base multiplied by height. Okay, then we'll be able to solve problems. What is the second type of triangle? Second type of triangle is if I have a triangle like this, right? I either have it like that, right, or I have it like this, right? It can be anywhere. It can also be like this, right? It can also be like what? Yeah, if it's like this, so if it's not like, if it's like that, or it's like this, or it's like that, those three triangles, no, rather, there we have triangles that share the same angle, share the same angle. We do have triangles that share the same angle. The bigger one shares the same angle as this one. The bigger one shares the same angle as that one. The bigger one shares the same angle as the smaller one there. So that angle is called an included angle. Included angle. It must be the one that is between the V. Okay, so if we have something like that, we use area rule to find the area. we use area rule. That's it. Okay. Then, you know, for higher and more complex problems, you do like we just did, but that one you rarely comes ne. So the most important ones will be these ones there, but yeah, just know them. Please master these for me. If you can just master these for me, you're gonna be okay. You're definitely gonna be fine, right? Are we all happy with this? Can you raise a hand if you are happy with that? If you need somewhere where you don't understand, you can just tell me. Okay, no, perfect then. Since we are all in sync in terms of that, guys, that was how we deal with areas on the proportionality theorem. So on top of this, you just need to remember how do we approach questions in proportionality theorem, and then how do we approach questions, yeah, to solve problems. I think if we can check our last recording, you remember where that problem whereby we needed to use those method I showed you, right? We found one of the challenge questions there. And that problem, I realized later on, that no, on top of exhaustion, Mina was focused on getting X before finding that other side, you see. So now it messed my brain up. I started to think too much hard, on something that was quite easy. So just make sure that if you go there, guys, you remember the problems we're doing, and they show you how to use the proportionality and its converse. So here it's how to find questions with the areas. Okay, now we have a special proportionality theorem case. We have a special case of proportionality theorem. Now what were to happen if we have a triangle? What were to happen if we have a triangle, ne? And this triangle, right, it so happens that this side here is equal to this side, and this side is equal to that side. Let's just call it triangle A, B, C, D, E. What were to happen if you have this situation whereby this side is equal to that side and this side is equal to that side? Well, if we have a case like that, that means here B is the midpoint, right? B is the midpoint. Same this side, D is also the what? The midpoint. So because of this, guys, our conclusion or our deduction that we're gonna say, therefore BD will be parallel to CE. Our reason will be midpoint theorem. Remember we did this in grade 10, ne? So it's the midpoint theorem. So the conclusion will be to say BD must be parallel to CE. And it doesn't end there. The other conclusion is that BD is gonna be half of CE. Okay, which means BD is gonna be half of CE. If CE is 60, BD is gonna be 30. If CE is 40, BD is gonna be 20. If CE is 10, BD is gonna be 5. You understand? So still the same reason. You say midpoint theorem. Okay, midpoint theorem. Where can we apply it? Where can we apply the midpoint theorem? There were questions I found. There are questions that I found. When was it? They were just focusing on the midpoint. I'm not sure if I'll find them here. Where can we find those questions? Okay, I can create it because I remember it. I remember that question. It was like this. It was a beautiful triangle. Just that Mina, guys, it's difficult to draw it exactly the way it was, but it was something that really smelled like this. So this is A, B, C, then we have D, EF, then we're given that this is equal to that, this is equal to that, this is equal to that, right? That's what we were given there. Then you are given that here it is x, this is x minus 2, and this is x plus 1. Look at how beautiful that is. Then you know what the question said? The question said find the perimeter. Find the perimeter of triangle ABC in terms of x. Yes. Find the perimeter of a triangle ABC in terms of x. Is there anyone who can guide us as to how they can do this? It looks scary, eh? It's not scary, guys. Just very, very easy there. What you need to do, the midpoint theorem applies as long as you have two midpoints. The line joining the midpoints will be parallel to the third side, and it will be half of the third side. Now I want you to check there. Since BD is equals to AD, right? We can say this is given. BD is equals to AD, which is given, right? And then BF is equal to FC, which is also very much given, right? And then AE is equals to EC, which is also what? Given. So because of this, guys, that means BD here is a midpoint. This is a midpoint. And then here it is also a what? A midpoint. And then here it is also a what? A midpoint. So because we have these midpoints, guys, we're going to start with these two midpoints. Because we have these two midpoints, the line that joins the midpoints is going to be parallel to the third side, which is this one. They're going to be parallel. And it's going to be half of that third side. You understand? So that's what we're going to say there. We use the midpoint theorem. As long as you have two midpoints, guys, that are joined together, you can use this. So now you can say DF is equal to DF, is parallel to AC, meaning this is parallel to that. What is our reason? We say midpoint theorem, because we already know that we have two midpoints there. And then therefore we can say DF is equals to half of AC. Still midpoint theorem. Okay, midpoint theorem. So DF is X, and then we have half of AC. If you multiply by 2 both sides, what are you gonna have? Therefore, AC is gonna be equal to 2x. Nice. So now you know that the length of this side is 2x. Right, then what can you also go to? You can also now use these two midpoints, this midpoint and that midpoint. So you can say since E and F are midpoints and you have a line that is joining the midpoints, that line will be parallel to the third side. You understand? It will be parallel to the third side. So you say FE is parallel to AD or AB, right? You're still using the midpoint theorem because you have two midpoints. And then now you also say FE is gonna be half of AB. So FE is X plus 1, and then you're looking for AB. Now how do you get AB, guys? You multiply by 2 both sides. Even this one, you're gonna multiply it by 2. Remember to put brackets. So therefore your AB is gonna be equal to 2 times X is 2X, 2 times 1 is gonna be 2. So you now know that AB here is gonna be 2X plus 2. Now similarly, you can also get BC. How do you get BC? You check. D is a midpoint, E is a midpoint. The line joining the midpoints is DE. So that line is gonna be parallel to this line here. So you tell them that DE is parallel to BC because of the midpoint theorem. And then you tell them that DE will also be half of BC. Still, it's the midpoint theorem. And because of this now, DE, remember, it's x minus 2 and then times half of BC. If you multiply by 2 both sides, BC is going to be equal to 2x minus 4. So this is what we have. So this side here is going to be 2x minus 4. So now that we have that, guys, we can simply get the perimeter now. Okay, so how do we get the perimeter? We then say, therefore, the perimeter of triangle ABC will be equal to the length of AB plus BC plus AC. That is the perimeter, it's the distance around a shape. So AB is 2x plus 2, BC is 2x minus 4, and then AC is 2x. If you add them, 2x plus 2x plus 2x, that gives you 6x, and then 2 minus 4 is minus 2. Then you are done, guys. That's the perimeter there. Okay, that is the perimeter there. So very nice stuff, guys, very nice stuff. You just have to understand that as long as you have two midpoints, the line that is joining those two midpoints will be parallel to the third side, and also it will be half of the third side. Okay, and since you know that also is parallel, now you can also use the proportionality theorem, you understand? So that's how the midpoint theorem works there. And then the converse of the midpoint theorem. How does the converse of the midpoint theorem work? Well, it's also not difficult. You just have to understand that now, if you have a line, a triangle ABC, and in that triangle, you have this line being parallel to that, and then you're given that AE is equals to EB. So you are given, for converse, if you have one midpoint, and you have a pair of parallel lines, or you are given that the line is half of the third side, right? If you have any of that situations, your conclusion, what will be your conclusion? Your conclusion will be to say AD, this must also be equal to that, meaning that you must have another midpoint. That will be your conclusion, to say D is also a midpoint, meaning that is equal to that. That's the conclusion. Reason being what? You say converse midpoint theorem. You say converse midpoint theorem. Guys, trust me, there are many instances where that converse is gonna assist you. Many instances. So please capture it right now, understand it right now, that whenever the situation is like that, we can use it. I had these nice questions, man. I think it's from the handbook. Let me just look for the textbook called Handbook Mathematics. That book has nice questions on the midpoint theorem that I just wanted to show you, so that you know how do we apply this midpoint theorem thingy. Oh my goodness, just forgot the page number, but I will find it now, guys. Please have patience with me. Oh yeah, I got it. Let me show you here. Let me show you here. Hey guys, need to be careful. So I agree you got how the midpoint and the converse look like. Let's see. Here's a problem here. Can you try to apply the midpoint theorem and the converse to find the answer? They want the length of FG. I'll just give you 5 minutes. Okay, guys. Yeah. Hope that you managed to get it there. If you got it, you can just post for me what you got there. So this is gonna apply the midpoint theorem. And how do we then do this? First of all, we're given that A is equals to EF here, right? And then AB is equal to BC is equal to that. Guys, if you focus on this triangle here, you can already see that there is a midpoint, there is a midpoint. So because of that, I can already say that BE is gonna be parallel to CF, midpoint theorem. At the same time, BE is gonna be half of CF, midpoint theorem. Okay, so we know that if BE is X, CF is gonna be 2X. But the problem is I don't even have BE. You see, I don't have BE. So I need to find BE, but we know that this is parallel. So since it's parallel, guys, what do you realize here? Remember I said if you have a parallel line and you cut it, I'm gonna repeat again. Remember I said if you have a parallel line and you cut it by a line, make sure that this sign is also in here so that you can actually unlock a new triangle you can work on. Guys, that's so important. Please remember it. That's very important. So now you see it opens new possibilities in this triangle. What are the possibilities? Very nice. Check. This is a midpoint because this side and that are equal. This is a midpoint, and we are told that CG, and we know that CG is parallel to BE. So this is the converse. So we can say since C is a midpoint of BD. You don't have to write this, guys. I'm just writing it so that I can see. And then CG is parallel to BE, but this one you need to write. So this one we already, it's already proved. It's already proved because CG is part of CF. We can write CF is a straight line if you want, but yeah, it's just that. You have one midpoint and a parallel line. Immediately you have those two things. You can then say, therefore, it means DG will be equal to GE. You say converse of midpoint theorem. Converse of midpoint theorem. So it's just simply about then concluding that this one here will also be equal to that one. And because they're equal, you can then say, therefore, that means CG is gonna be half of BE. CG is gonna be half of BE. What is our reason? Our reason is midpoint theorem. And currently now we have two midpoints, so we can say midpoint theorem because you now have 2 points, two midpoints, which is G and C that are joined together. Two midpoints that are joined together. Two midpoints that are joined together. Let's remember that. Okay, so CG is 30, and then we don't have BE. Remember, we needed BE. Remember that other time. If you multiply by 2 there, therefore your BE is gonna be 60 units. So now we know that this is what? 60 units. And if this is 60 units, now it allows us to find CF, because now we can say 60 is equals to half of CF. If you multiply by 2 both sides, guys, just a matter of multiplying by 2 there, you get that CF is 120 units. CF is, this whole thing is what? 120 units. And CF, since it's 120, now we can get GF or FG. Therefore, FG will be 120 minus 30, which is 90 units. Which is 90 units. Beautiful, 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 guys. So I hope that you understand that, guys. As long as you have two midpoints that are joined together, right? Two midpoints, I can't help it. As long as you have two midpoints that are joined together, right? That line that is joining the midpoint is going to be parallel to the third side. And at the same time, that line is going to be half of the third side. What did we say? Two midpoints that are... wow, that's... well, if I was teaching grade 12, still teaching grade 12, this was going to be a beautiful song. Two midpoints that are joined together. Two midpoints that are joined together. That means midpoint theorem. Oh, yeah. Thank you, guys. I'm going to go to my grade 10s. You know, we're going to be singing that. Two midpoints that are joined together. And it's going to be that line that is joining the two midpoints is going to be half of the third side. And it's also going to be parallel to the third side. Then if you have one midpoint and a pair of parallel lines, you can conclude to say the other side is you have a midpoint. That's the converse now. Okay, I hope that is clear, guys. Are we happy with two midpoints that are joined together? Are we fine there? Please, if you're fine with that, you can just raise a hand so that I know that you heard it and you are fine. Eh? You good, Mr. Fatai? Okay, good. Okay. Any question? Any question? If we don't understand it, you can just tell me. Maybe where can we repeat on that part? Okay. But I hope we understand midpoint theorem. It's gonna be helpful in some of the problems we'll be dealing with. Okay. So that's just about two midpoints that are joined together. The line that will be joining those two midpoints is going to be parallel to the third side, and it's going to be half of the third side. Which then brings me to this. Similarity. Similarity problems, guys. Here we have come to the most easiest problems ever. The most easiest problems ever. If you thought midpoint theorem was easy, this one is much easier. You know about similarity, ne? You just need to understand the properties of triangles. But let me help you to understand similarity. Similarity means that things are similar because they have the same angles, but they have the same corresponding angles, but they don't necessarily have the same size. For example, look at this triangle here. Ne? Let's just say here it is 60 degrees. Here it is 70 degrees. 70 degrees. And then here it is how much? 60 plus 7, 130. So here it is 50 degrees. Okay? If I take this triangle and make a copy of it, but make it bigger. Now this thing is disappointing me. Why can't it make it bigger now? Guys, this thing was supposed to be bigger. Shame. This board, I now have to do it manually. So here's a triangle again, and this triangle here, we have 60 degrees, we have 50 degrees, and then here you have 70 degrees. Guys, as you can see, all the corresponding angles, right? All the corresponding angles are equal. When I'm saying corresponding angles, I'm not talking about those ones that are F-shaped. I'm talking about angles that are on similar positions. You see, this one is down here on the left. This is also down on the left. This is down on the right. This is also down on the right. This is up. This is up. So they are in corresponding positions, which means they are in similar positions. Okay? So those corresponding angles, they are equal. If all corresponding angles are equal, we say those triangles are similar. Those triangles are similar. We can use the symbol. You can write it like this, or you can write it like this. Is fine, but we like it more like this. So this is to say they are similar. Okay, they are similar. But does that mean that the sizes are the same? No, doesn't mean that the sides of the length of the sides are the same. No, the length may be different, but as long as the angles are the same, the triangles are similar. So when we are proving similarity, we are proving that the triangles have corresponding angles to be equal. Now let's have a simple example. Let me say I give you this triangle here. Let's call it ABC. And then I say to you, this is 80 degrees here. And then this is 40 degrees. And then I give you a triangle KFC, triangle KFC. Now then I say to you, this is 60 degrees, no, this is 80 degrees, and then this is 40 degrees. Then I say to you, prove to me that these angles are similar. The nice thing about it is that you just need to prove that the two pairs of angles are equal. Then the other one, you just say third angle. So what you're gonna say, in triangle ABC and triangle KFC, you're gonna say angle B is equal to angle F, which is given there. You can see it. Then angle C is equals to angle C there, which is given there. So because of this, we can say therefore that means angle A will be equal to angle K. Our reason, we simply say third angle. We don't have to prove it. We just say third angle. As long as we've proved that two angles are equal, two pairs are equal, that's it. The third one, we just say third angle. Then from there you can simply say, therefore, triangle ABC is similar to triangle KFC. Your reason being what? Angle, angle, angle. Or you can use AAA if you want. You can use AAA. So you always use that reason, guys, angle, 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 when you're dealing with similarity. Yeah, that's how easy it is, guys. But now, it doesn't end there. The fact that they are similar means the sides are also in the same proportion. So what it means is that now this over that will be equal to this and that. So you just make a nice frog there, guys. Always make this nice frog. I always say the eyes are here and your frog is smiling. The eyes are here and this frog is smiling. So what it means that you're gonna tell them that AB over what? Over KF is gonna be equal to BC over what? Over FC, which is equal to AC over what? Over KC. Reason being what? You just tell them from similarity. That's it. Just tell them from similarity. And then it's gonna assist you there. That thing is gonna assist you for answering questions. Okay. So I hope that it's clear, guys, how to answer similarity questions. Just prove that two pairs of angles are equal. Let me show you why similarity is quite important, especially in the triangles. Let me say I give you this. Right. Then let me call it triangle ABC. Then here we're going to have D and F. Now let me say that, let me say I'm looking for, let's just say this is 5, this is 2, this is 8. Obviously, if I say 2, it will be 2k. That's the ratio there, 5k. And then this one, you can call it 8p, right? And then I tell you that this is parallel to that. Okay? Then I say to you, find for me, find DF. Let me see. ABC, ABC, BC, ADF. Yeah, I want DF over BC. How would you find DF over BC? Now, remember, this is not the midpoint theorem, the converse. Ne? Why is it not the converse? Because D is not a midpoint. D is not a midpoint. This and that are not equal. If they were equal, you are going to say AF over FC is also equal. You use converse. But this is not converse. Okay? You just have a pair of parallel lines. However, the proportionality theorem does work. So you can use the proportionality theorem and say AD over BD is going to be equal to AF over FC. Then you say line parallel to one side of a triangle. Now AD is 5k, BD is 2k, AF, so that means you don't have AF, you don't have FC, but they also give you 5 over 2. AF over FC also give 5 over 2, which means here we can use 5p, here we can use what? 2p. Let me just use a different letter there now. Let me use Z, 8z. Now guys, still, even if you can use the proportionality theorem there, you still can't get DF over BC. I can bet. The proportionality theorem is not going to help you to get DF over BC. Unfortunately, it's only similarity that will help you. But how does similarity apply here? Well, let me show you something. Look at AB, AC, and then like look at this big triangle, and then I want you to look at this smaller triangle, this one, ADF, right? These lines are parallel, right? What does that mean? That means this angle is gonna be equal to this angle. And what this it also means, this angle is gonna be equal to that angle. Why? These form an F shape. They are corresponding angles since the lines are parallel. So we can definitely say, oh, so in triangle, check. It's also very important how you name your triangles. This one, we don't play. We don't just say however way you name. You want to name consistently. So I'm going to say triangle ADF. Okay? So I'm going to say triangle ADF. If I said ADF, on the bigger triangle, I must say ABC. So I'm going to say ABC. They must follow the same order. Then now I can say triangle. Actually, let me just call this D1 and D2. Call this F1 and F2 to make my life easy. So angle D1 is going to be equal to angle B, reason being that they are corresponding angles. Which lines are parallel? It's DF being parallel to BC. And then angle F1 is equal to angle C. They are also what? Corresponding angles, because DF is parallel to BC. Guys, because of this now, we can therefore say, and then angle A is common. Or we can simply say, angle A is in ADF and it's also in ABC. You can say angle A is common, but it's a third angle. You don't have to even worry about it. Or you can just say angle A is equals to angle A, your reason being what? Third angle. Because you already proved two pairs are equal. So therefore you can then say, therefore triangle ADF will be similar to triangle ABC. Reason being what? Angle. Then you start with the frog now. Hey, must be careful with the frog. Then now what can you say? You can say AD over AB is gonna be equal to DF over BC, which is equal to AF over AC. You say from similarity. And now that you have that, guys, you are literally almost done. What you just need to do now is to check what did they ask you for. They asked you to get DF and BC. So what you're simply gonna do is that you're gonna tick where you find DF and BC. So this is DF here, this is BC. You see, that's DF, that is BC. So where you find them, you just write that ratio, and then you just check the other ratio you want. You just need to choose two things. You can either choose these two or you can choose these two. So I'm gonna choose to use DF. I'm just gonna say therefore DF over BC is equal to AF over AC. Now what is AF? AF is 5p. What is AC? AC is 7p. Is 7p. So therefore the answer there will be 5 over 7. Then you are done. Then you are absolutely done. It means, yeah, I made a mistake by putting 8. It's actually not 8 there. It's 7. It's for DF is 5. It's 7, not. So it's 7Z, and then here it will be 5Z. It will be 5Z. So guys, that is how you apply the similarity theorem. You just have to check the angles, two pairs of angles that are equal, right? And then the third one, you just say third angle. Then you'll be done. That means that you can now say your things are similar, and then you say the corresponding sides are also in the same proportion, meaning that thing of using the frog. Then you just find whatever ratio they're looking for, where now you're just simply going to you're simply going to relate those two, but then you can be fine. Now let me actually also leave you with this question. I want to see if you still remember. What if I said to you, right? What if I said to you, find for me the area of triangle ADF over the area of triangle ABC? How would you do this, guys? Is there anyone for me? Okay. Are you seeing it, guys? It's gonna be quite easy. Remember, it's the one we did before. Which case is this one? Remember, we have a case whereby we have that beautiful triangle I gave you, right? Or this one. Then we have a case whereby the angle, the side is here, or the side is there, or side is there. What we said is that they share the same angle. As long as those two triangles, they share the same angle, you use the sine rule. So here you're gonna say ADF. For ADF, you're gonna say half AD times DF, right? Then you say sine of angle A. Whereas for ABC, you're gonna say half of AB multiplied by AC. Then you say sine of angle A. Then what happens? This and that cancel. This and that cancel. Now what is AD? AD is 5K. What is DF? DF is 5Z. You see, you needed DF. You can't do this question without finding that 5Z. What is AB again? AB is 7K. Then what is AC? AC is 7P. Okay, so in this case it will be I made a mistake. It's not AD times A. It's not AD times DF. Do you see that? It's AD times AF. Sorry, I don't know where I got DF there. It's AF. It's AF. Because remember, it's the V. It's the V that makes up those sides. So it's AF, and AF is given as 5P. So here it's P. So that P and P cancel, right? Then your answer is going to be 25 over 49. Okay? So that's how you do that, guys. So questions that are going to ask you about areas, questions that are going to ask you about midpoint theorem, similarity. Good people, you have the whole Euclid in your hands. What is just left is for you to apply. And then the theorems, you know, we need to prove the theorems. I gave you the link to the proof of theorems, guys. Use that method. You'll be able to prove that. Okay, so I'm gonna give you a test, and then please make sure that you submit it before 11 p.m. tomorrow. Please submit it before 11 p.m. tomorrow. Then on Wednesday you will have your results there. Then we have maths again on Wednesday. Okay, we're gonna be doing financial mathematics. So yeah, I hope that is clear, guys. Have yourself a great time, and if you have any questions, you are free to ask me, but otherwise, peace out.